Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and lecture number 18 on chemical kinetics. We are discussing numericals related to second order reaction. Okay, so investigate one more numerical. Investigate the reaction between hydrogen peroxide and HI. For that we have to prepare sets. Set 1, bottle number 1, in which we take 10 ml of 0.1 normal H2O2 plus 40 ml H2SO4. Bottle number 2, 10 ml 0.1 normal Ki plus 40 ml H2O. Now we have to prove that this is second order reaction. Prove that it is second order reaction. And you are given table, time in minute, and burette reading, that is volume of sodium thiosulfate. So after 10 minutes the volume is 8.5 ml, 20, 13.0 ml, 30 ml, 30 minutes, the burette reading is 15.5 ml. At 40 minutes the burette reading is 19.0 ml. At 50 minutes the burette reading is 21.3 ml. So these are burette readings or volume of sodium thiosulfate required. Okay, titrate 10 ml of mixture against 0.002 normal sodium thiosulfate using starch as an indicator. Well, to find out whether this is second order reaction or not, first of all we have to calculate small a and small b. Okay, so now total volume of both the bottles when we mix them will be 100 ml. So first of all we'll have to find out effective concentration of H2O2 in total volume. For that we write N1V1 equals to N2V2. For N1 is concentration of H2O2 into volume of H2O2, that is 10 ml, and now volume will be 100 ml, and therefore N2 is equal to 0.1 into 10 upon 100, which is equal to 0.01 normal H2O2. So this is effective concentration of hydrogen peroxide. Now we will go for calculation of A. And for that again we write N1V1 is equal to N2V2. N1V1 is for hydrogen peroxide, N2V2 is for sodium thiosulfate. N1 is effective concentration of H2O2, 0.01. Volume we have to prepare 10 ml, so V1 is equal to 10 ml of the mixture. Now N2 is 0.002, which is given. and V2 will be small a. So V2 is equal to 0.01 into 10 upon 0.002, and that is equal to 50 ml. So this is small a. Okay, so small a is 50 ml for this reaction. Now we'll find out small b, and for that, first of all, we should find out effective concentration effective concentration of Ki in total volume. So here we write N1V1 is equal to N2V2. So 0.1 normal Ki, 10 ml of Ki. Now total volume is 100. Therefore, N2 will be effective concentration, which is equal to 0.1 into 10 upon 100, which is equal to 0.01 normal Ki. Now, for calculation of small b, we write N1V1 is equal to N2V2. N1V1 will be for Ki, N2V2 is for sodium thiosulfate. So for effective concentration of Ki is 0.01, volume of Ki 10 ml, which is equal to concentration of sodium thiosulfate 0.002 into V2. So V2 is equal to 0.01 into 10 upon 0.002, which is again 50 ml, and that is small b. So here we can say that A is equal to B. Therefore, we have to find out K using that formula of second order. So first of all, table is of time, then burette reading X, then A minus X. Here A is equal to B is equal to 50 ml. Okay, then we can have 1 upon A minus X, and then finally K is equal to 1 upon AT into X upon A minus X. Okay, so first of all, at time 10 minutes, 20 minutes, 30 minutes, 40 minutes, and 50 minutes, the burette readings are 8.5, 13.0, 15.5, 19.0. These are given. 21.3. Okay, A is equal to 50. So 50 minus 8.5 is 41.9. 50 minus 13 will be 37.0. 50 minus 15.5 will be 34.5. And 50 minus 19 will be 31.0. And 50 minus 21.3 would be 28.7. Okay, and 1 upon A minus X you can find out. Okay, like for this it is 1 upon 41.0.9 is equal to 0.024. So you can find out all this, and then K. This is K1, then K2, K3, K4, and K5. Okay, and if you are getting K1 is equal to K2 is equal to K3 dot dot dot, then you can say that this reaction is of second order. So this way we can find out order of reaction by calculating K. Okay, so I think this is enough in this lecture. Thank you.